My wife is headed to her 3rd Olympic Games. In Rio, she took 4th, and in Tokyo, she made it to meme status, but this time is going to be different. I've been doing rapid product development for over a decade now, so identifying particular needs and engineering solutions to solve those specific issues is what I do. So the place to start is the start. So we've hacked this set of track blocks to be able to record and show the reaction time. It's connected wirelessly to the control remote using the ESP-NOW protocol. And all of these things are battery powered, so it can easily be brought out to the track and used in a training session to give her start reaction time. And then after discussing it with coach, we identified that we needed to also have a time gate to identify her initial speed to 15 meters. So we're able to detect her speed up through the drive phase, through the first hurdle, and then into the time gates. Every time you cross this beam, it detects the beam being broken and it sends a signal back to the main blocks and records that time. And the coach or I can start it by using, you got 2 buttons, one for set and one for start. The start will only go if the athlete is actually in the blocks and pressing, because we're detecting the release of pressure, not a spike in pressure like some of the official systems work. But because of that difference, my time will always be shown as slower than real time, which is not a bad thing because it encourages her to continue to push. We can see where she is relative to herself. So I hacked an existing set of blocks by putting force sensors underneath the rubberized outer coating. So I measure when that force is released and identify that as her leaving the block. When you press the start button on the remote, it sends a wireless signal back to the main block system, which is based on the ESP32 platform. That sounds the start signal and starts collecting time and looks for the release on the force sensor on the foot pad. As soon as it sees that past a specific threshold, it captures that time. This is her reaction time. It also sends a signal out to the time gate, giving the time code of the main blocks so that they can correlate their time codes and identify the difference between when she starts and when she hits the time gate. That information is then wirelessly transferred back to the starting system and displayed on the little 7-segment display on it. A lot of the design decisions were based around what was readily available off the shelf and could be quickly modified. So the battery pack system that you might have noticed in the blocks and also in the time gates is these Ryobi batteries, because Ryobi, unlike some power tool manufacturers, actually has a BMS built into the system that can actually turn off the terminals if the battery's over discharged. So I didn't have to incorporate a battery management system in my design. All I had to do was have the DC to DC converters to provide the appropriate voltage to the micro and to the gate detection sensors, which were actually pulled from a garage door sensor. Being an engineering prototype, it incorporates a lot of electronics as well as a lot of 3D printed parts in order to prove the concept. But so far, it has shown useful on the track, and I ask you to join me in cheering on Cindy Sember as she attacks Paris 2024. Let's see, what am I going to say here on this one? A lot of the design decisions were maced